Hi guys, in this video I'm going to talk about using graphs to factor. So a skill that we've been working on for the last few days, but we're going to approach a topic that we haven't talked about yet, which is what happens if I go through and I graph and I have some zeros and they're fractions or decimals and they're not nice neat numbers, okay? How can I approach that? Okay, so I want you to understand as we talk about this, we're talking about nice neat decimals like 1.5 or negative 1.3 repeating, things that we can easily turn into fractions. We call those rational roots. Rational meaning ratio, okay? These are rational roots that we're looking at, which means ratio, which means fractions, okay? We're not talking about like the square root of 5, for instance. If you went and typed that in your calculator, it'd be a decimal that doesn't repeat, and it'd be a decimal that doesn't end. Okay, if it doesn't repeat itself, like the 0.3 repeating, or if it doesn't end, like the 1.5 ends, okay, these are easy situations to deal with. Something like pi, for instance, 3.14159265, blah, 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 it goes on forever. See, that's not a number that we can write as a fraction, okay? So we wouldn't be able to necessarily do that problem. So one more time, just to set this up, I go and I graph it, and I see that it has maybe some whole numbers, but also has some fractions, but those fractions either end, like the 1.5, or they repeat, like the 0.33333, okay? Because what the first step is to doing these problems is finding out what's the fractional form of that decimal, okay? So my calculator has given me these values. Can I write 1.5 as a fraction? 1.5 would be 1.5, which is 1 and 1/2, which is 3 halves, okay? That'd be necessary to be able to write. 1.33333 repeating would be negative. It's negative over here, and it's 4/3, 1 and 1/3, right? So if you can get to that format, the question is now, can we go through and can we do the same thing? So here's the fraction. That, by the way, that's the polynomial that I have, right? Okay, so what I want you to see here is that there's an incorrect way to do this. The problem is I need to end up with a 6x cubed. Remember that, okay? So that's going to come into play here in a second. And the old way of doing this, what we were saying earlier, is if I went through and I just wrote out x minus 2 for this root, and x minus 3 halves for this root, and x plus 4/3 using the same steps that we've been using already. The problem is whenever I go to FOIL this out, and I'll do this real quick for you, okay? If I multiply the first two out, that would give me x squared minus 3 halves of x minus 2x plus 3, okay? If I FOILed those out, okay, notice that it's minus 3 halves x and it's minus 2x from the inner terms. The last terms is a negative times a negative, which gives me positive. And 3 divided by 2 times 2, the 2's go away. That ends up with just a straight 3 here, okay? Now I need to multiply that times x plus 4/3, okay? Now I've got to combine the two. Before I do that, I would probably want to go through and go ahead and combine like terms here. That's going to make it a little bit easier to FOIL. So that's minus 2x's and minus another 1.5 x's. So that'd be a grand total of minus 7 halves x plus 3 times x plus 4/3. Okay? Just trust me on that. Now, remember, I'm going for a 6x cubed in this. And you'll see the problem, and this is the last step that I'm going to do. The x cubed comes from the multiplying the x squared times the x here. That's the only way to get the x cubed in this problem. And whenever I distribute out the x squared, I end up with a single x cubed as my very first term. Okay? And then you've got some other stuff, you know, that's going to go on beyond that. But I don't really care about that. The problem is I only have one x cubed. So whenever I go through and I simplify this, this cannot be the correct factorization because I don't have 6x cubed, I have 1x cubed out of this. The x times the x times the x. So where's the 6 come from? So here's what we're going to do to correct it, okay? First of all, the easy one, the 2, that rule still holds in place. It's still going to be an x minus 2. What's going to change is the two fractional pieces. And so the easiest way that I can tell you to do this is the following, okay? This is the easiest way to get to the answer. You see that 3 halves is a 0, right? The 3 halves is still there. So I know that x minus 3 halves was supposed to show up as a 0, okay? So I'm going to set it equal to 0. And all I'm going to do then, if x minus 3 halves is supposed to give me a 0, let's multiply every single thing in here by 2. Okay? That means that the 2 gets distributed out to the x and the 3 halves and the 0. I'm going to multiply, or you might think of it this way, okay? Maybe this is an easier way. I'm going to multiply every single thing times 2. I'm going to choose 2 because that gets rid of the fraction, okay? So now I have a 2 times x minus, the 2's go away here, and that leaves us with a single 3 on top, and 0 times anything is 0. See, here's the thing. If I would have, instead of saying x minus 3 halves, if I would have said 2x minus 3, that still gives me to the positive 1.5 that I was looking for. So in other words, there are multiple ways that I can say that x should have been 1.5. Notice once again, watch this. If I solved this for x, let's just work backwards for instance, okay? I would have said 2x is equal to 3. I would have added 3 to both sides, right? So give me 2x plus 3, and then I would have divided by 2, and x would have been 1.5, 3 halves. That's exactly what I was looking for, right? So the correct factorization is not x minus 3 halves. The correct factorization is 2x minus 3. And we can do the same thing here for the 4/3. See, it's not x plus 4/3. That's not what we want. Really what we're going to do is we're going to multiply both fractions, or every single term by 3, because that gives me 3x's plus, the 3's go away here, there's a 4, it's equal to 3 times nothing is nothing. And so it's not x plus 4/3 that we wanted to go in there, it's 3x plus 4. So the correct factorization of the original equation, which is 6x cubed minus 13x squared minus 10x plus 24. The correct factorization is this format. Now let me prove it to you real quick, okay? So here we go. I'm just going to prove the answer by going through, and I'm going to FOIL everything out for you. Okay, so here's what we have instead. X minus 2, 2x minus 3, 3x plus 4. Let's take these two and FOIL them out. That would give me 2x squared minus 3x minus 4x plus 6. That's these two. Notice once again, the last term, negative 2 times negative 3 gives me positive 6. That's important, okay? I'm going to go ahead and combine like terms. That's a minus 7x. So I get 2x squared minus 7x plus 6. And then I need the 3x plus 4 to be distributed out to it. When I distribute out the 2x squared, I end up with 6x cubed plus 8x squared. That's distributing the 2x squared to both of these terms. When I distribute out the negative 7x, I end up with minus 21x squared and minus 28x. And when I distribute out the 6, I get 18x and 24. Combining like terms, that leaves me with 6x cubed. As far as the x squared goes, it looks like I got positive 8 and negative 21. That's minus 13x squareds when I combine these two. When I combine the x's, that looks like negative 10x's. And then I have the oddball 24 off at the end. And you'll notice, look, 6, negative 13, negative 10, 24. The original equation, 6, negative 13, negative 10, 24. It all checks out. So hopefully that makes sense. This is how we take care of the rational roots, which means numbers that can be rewritten as fractions. Not the messy decimals, not imaginary numbers, none of that, right? But how can we get from here to here whenever we have fractions involved? So that's the big trick for today. We'll also do some quadratic equation and stuff, so don't forget all those tricks. And hopefully this helps you out.